This video is just going to be a recap of what we already went over. So if you feel like you're not yet comfortable with finding when the particle is speeding up or slowing down, then watch this video and maybe it'll help. Otherwise, you can just start on the assignment and finish it. So here we go. Okay, so we already know how to find if a particle is moving to the left and to the right. That's just by looking at its velocity function with a sign chart. So you'd have to set it equal to 0 to find the critical points and then pick test values so that you can do a sign chart. Here it says find the intervals of time when the particle is speeding up or slowing down. Yesterday in class we wrote down what it meant if you had velocity positive, acceleration positive, then the particle is speeding up, velocity negative, acceleration positive, the particle is slowing down, and so forth. Those 4 scenarios. We're going to be using that. So if you don't have that written down, maybe look at a neighbor's notes and write that down. Just when is a particle speeding up and slowing down, there's a list of 4 scenarios. So after you have that written down, you remember that, then we can start this problem. The question is, or the task is, to find the intervals where the particle is speeding up and also when it is slowing down. So what we're going to do is first we're going to need our velocity function and our acceleration function. And you get that by just taking the derivative of position. So velocity is a cubic function, and acceleration, that's just going to be the derivative of velocity. So that would be, and there we go. So that's what we do first. And then we're going to do a sign chart for velocity, and then we're also going to do a sign chart for acceleration and see where they overlap. So, and see where positive and negatives overlap. We're going to interpret stuff. But our task now is to make a sign chart for v of t. So for v of t, I'll just set it equal to 0. And I'll solve. In this case, even though it is a cubic function, I can still factor out a common denominator. Common multiple. Common factor? Common factor. That's what it is. That's why it's called factoring. Alright. Well, I can factor out a -4 and also a t squared, right? So I'm left with just t on the inside. If I multiply that in, yes, I get that. And also, that's 9. That's a minus then. Minus 9. Just minus 9. Okay, so I factored it, and to solve this, I set each piece equal to 0. Squared equals 0, and t minus 9 equals 0. I'm still finding my critical points, divided by -4. And so we have t squared equals 0. It's just t equals 0. This is a double root. Not that that matters, but it's just a double root. We know it's a double root because you get 0 twice. It has a degree of 2, or a multiplicity of 2. That's all that means. Here, plus 9, so t equals 9. So the critical points are t equals 0 and t equals 9. However, remember, t can't be, it has to be greater than or equal to 0. It can't be smaller than 0. So for our sign chart, I have one critical value as 0 and the other one as 9. And I don't have to pick anything below 0. So here will be my test points, and then here will be the sign of v of t. So we're plugging in test points, which I'll do. Sorry, this is supposed to be above the line. So that's a 9 there. So this, I'm just going to say this is going to be 1 and 10. And I'll plug those in and see which signs I have. The only reason I don't do anything down here is because t can't be smaller than 0. So, maybe that can extend. If I plug in a 1, I can either plug it in to my original and see if I get a positive or a negative, or I can plug it in to my factored form. And it's actually easiest to plug it into the factored form. So, on the outside here, this is always going to be positive, times a negative, always this piece will be negative. So it will be a negative times, even if I plug in a 1. 1 squared is just 1 times -4 is -4. So that's a negative times 1 minus 9 is a negative, so that will be a positive. And then if I plug in 10, I get a negative times a positive, which gives me a negative there. So that was my sign chart for v of t. Now I'm going to do the same, almost the same exact, well actually yeah, all the same exact steps, and make a sign chart for a of t, which is the acceleration function. So again, I just take that, set it equal to 0, so I can find my critical values, my critical points, plus 72t. And, well, again, I can factor I factor out a 12? Yes, I can. So 0 equals, I'll factor out a negative 12t. So I'm left with just positive t minus 6. 6 times 12 is 72. Is it? Yes, it is. So I have this. If I distribute it back in, yep, I get that. Okay, set each piece equal to 0. Divide by negative 12, divide by negative 12. Of course, t equals 0, so I get t equals 0 again. That's nice. And then t minus 6 equals 0 plus 6. So t equals 6, and t equals 0. And then I'll do my sign chart. Same way. 0, I don't have anything on the left side because t can't be smaller than 0. And there we have it. So this will be my test points, my test values, and then sine of a of t. So I'm plugging this into a of t, all my test points. Something I don't have to do anything below 0 because t can't be negative. So I'm just going to pick 1 and 7. And then I'll plug it in. It's easiest to plug it into the factored form. So if I plug in 1, I just get 1 times negative 12. That's a negative. And then here, 1 minus 6, that's also a negative. Negative times a negative is a positive. And I'll plug in the 7, and I get a negative times a positive. That's a negative. Alright, so I have my intervals. Now, some of you can look at these and see where acceleration is positive and velocity is positive, or you can see the different things. But what I'm going to do is just draw a number line, and I'm going to include all of my critical points on the number line. Actually, I'm going to draw 2 number lines. So this is how I compare. If you think like this is good enough, you can write out the intervals now. Good, do that. If you need a little bit extra help, then you can write down these number lines. So it looks like I start at 0 and I have to go all the way up to 9, and then I'm going to include that 6 there. So I'm going to have a 0, a 6, and a 9 in each of my number lines. So for velocity, I'll start at 0 and I'll go upwards. So 0, 6 somewhere in the middle, and 9. So for velocity, I'll do stuff. And then for acceleration, I do the same exact number line. So 0, 6, I'm lining up everything as well. That's important. Okay, so when is velocity positive? Well, from 0 to 9, we have positive for velocity. So from here to here, it's positive from 0 to 9. And then from 9 to infinity, well, that's negative. So from here onwards is negative. Well, I'm not going to do that infinity part. But from there onwards, it's negative. So we have positive there, negative there for the rest. And then for acceleration, from 0 to 6, we have positive. And then from 6 onwards is negative, right? That's what it says. From 6 onwards is negative. So we have that, and that goes on forever. All right, now we see where they overlap. Well, it looks like in this section, v of t and a of t are both positive. And if you looked at your other notes, that means the particle is speeding up. And remember, they only overlap when they're both positive here. So it's speeding up from 0 to 6. We don't include 6 because at Well, at 6 it changes. It starts to slow down, right? Because from 6 to, looks like 9, that interval cuts us off. From 6 to 9 we have positive and negative. Well, that means we're slowing down. So, I'll write that. And then it looks like from 9 onwards, well, they're both negative, right? Negative times a negative would be a positive, so we're also speeding up from 9 to infinity. And there you go. Those are our answers. And I'm going to stop this video because it's too long.